What's going on, everybody? This is Future Automation, a place where imagination meets reality, and you're listening to Tejas. In today's video, we'll be learning how to use OLED displays with NodeMCU, although same we can use with Arduino and Raspberry Pi as well, but that will keep for some other videos. Today, it's about NodeMCU, Waveshare 0.91 OLED, and lots of fun. So, with a cup of coffee and lots of fun, let's get started. For this video, basically, we'll be having two sections, that is hardware section and the software section. And for the hardware section, what we need are only these three things. Number one is this NodeMCU, and number two is this OLED display, which is from Waveshare. So if we'll see behind, you can see the Waveshare logo and 0.91 OLED module, and also we need a power cable. So that's it. If your OLED display is not having these cables, so make sure you use the jumper cables. But for me, it came with the OLED display only, so I'm going to use the same thing. Now, for the software part, you need the Arduino IDE, obviously, without which we cannot do anything, and you need to install the ESP8266 boards. All the link will be in the description, but let me give you a quick idea about what we need to do. So for Arduino IDE, you need to go to the arduino.cc website, and there if you go in the software section in downloads, you'll find the Arduino IDE, so download from there. For ESP8266 boards, what you need to do is you need to copy uh, this link, that is the JSON link from this website, which I'll be linking in the description. Then we need to go in the preferences and we need to paste this link here, and then just if you click on OK, the boards will be automatically downloaded. And then we need to go in the board manager, and here you need to search for ESP8266, and you'll get the ESP. Although it is installed for me, you will need to install it. So once you'll install, all the ESP8266 boards will be installed here. And for ESP32 boards, you need to copy similar kind of JSON which is made for ESP32, and you need to paste it here and download the boards. And now for the part of libraries and the code, I'll explain you in a minute. So first we look at the hardware part. So what all things we are having. So this is basically the NodeMCU. Where to buy it, I will add the link again in the description, but we'll take a quick look at what exactly this board is. So if you'll see, we are having lot of digital IO pins. We are having 3.3 ground, RX, and this side we are having again V in, ground, reset, enable, 3.3 volt, then again ground, and lot of other digital IO pins, and also an analog pin. That is, if you'll see here, you can see there is a A0. So this is basically the analog pin, and there are many more pins. So I think you'll be getting the pinout diagram somewhere on the screen, so you can check it out. I'll link all the images as well in the GitHub repo so that you can use it. Now for the OLED screen, so this is really very small. If you'll see, comparing to my fingers, how small this particular OLED screen is. So this is just for an informative tutorial where you can understand how to work with OLED screens, but you can buy the bigger screens as well and you can try with them. Same logic applies everywhere. You just need to change the pixels of the display. So this is 128 by 32 pixel. You have 128 by 64 pixel, and then we'll go on. You can get that gist of what exactly I'm trying to explain. So here you'll get four pins. One is VCC, then ground, then SDA and SCL. So where we are going to connect these pins, I'll explain you in a minute. Same pins you can find here also. If you want to solder the pin instead of all this bulky wiring socket, you can remove it and you can solder it from here as well if you want. And here you can see they have mentioned 0.91 OLED module. Now let's go to the coding part. So connecting this and running this, I'll explain you in a minute, but first we'll try to understand a simple code for this particular project, and then we'll go for the compiling and burning. Now Coding part is pretty simple. Again, here the main thing that we need is these two libraries. So if you'll go here in the library manager, you can type in this name, and both the libraries are created by Adafruit. So you can just down install these libraries from the library manager, and that's it. Other all the three libraries are inbuilt, so you don't have to worry about them. You just copy paste whole code, install these libraries, and burn it out, burn the code in the NodeMCU, and you're good to go. Now next to that, next two lines define the size of the pixels in the screen. So we are having 128 by 32 pixels, so width is 128 and height is 32 pixels. Next to that, we are having OLED reset. So this is basically what we mention here, that the reset pin is being shared with the Arduino reset pin or the NodeMCU reset pin, so it doesn't have any of its own reset pin. Next to that, we are having a screen address. So here you can use all the data sheets provided by all the data sheets provided by Waveshare to understand what exactly this bit is and what it is representing for this particular display and other displays as well. Now here we are basically combining everything into this Arduino SSD 1306 display function. We are passing in the screen width, screen height, wire. So a wire is basically another library that we are using. So these two libraries are helps us in working with the I2C connections and how to connect these kind of modules with the NodeMCU or Arduino, and then the OLED reset pin. And once that is done, we are good to go to the next part. So this is basically before setup thing. You set up the libraries, you set up the width, height, you set up the pins, and you set up everything which is required for the module, and then you go to the once once deploying part of the code, that is void setup. So those who are new to Arduino, again let me explain that void setup is executing only once, and while loop is something that will be executing continuously. Now here you can see that we have not written anything in while loop because we are not going to perform any kind of looping operation. We are only going to display something that will stay on for a while unless and until you change the code or reset the code. Again it will start from first. So now in the setup part, so we are having serial begin. Although serial begin is not required if you don't want anything to be displayed in the serial monitor, I have just added it in case I was just working with a lot of trial and error for this code. Now here what we are doing is, here we are checking whether the display allocation, that is the pixel allocations, are there and the display is properly connected or not. If not, then we can just be in the loop forever and we do not do anything. If yes, then we just skip it and we go ahead. Now display. So basically display is a must function to display anything on the screen. Say for example, so initially if you are doing this display, it will display the Adafruit logo. Next to that, we are giving a delay of 2000 milliseconds, and then we are clearing out the display. So whatever we are displaying here will be cleared using the clear display function. So anything, if you want to change the text, if you want to reset the text, or if you want to clear out the display, you use the clear display function. Next to that, we are using set text color. As the name suggests, we are changing the text color to white, and there are many more colors that you can add: red, black, blue, whatever it is. So if you are changing the background, we are then changing the text as well. So now it's black. You can add white color, red color, anything. You can play with multiple options here, parameters, and then you can decide what looks better for your project. Next to that, we are setting the cursor. So cursor will be set at 10 to 1020 pixels. So 1020 pixel in the sense 10th by width and 20th by height pixel. So 10 20th coordinate pixel will be the starting point of whatever text you are going to display. Next to that, we are going to set the text size. So it varies from 1 to 8, I guess. Yeah, so 1 will be being the minimum and 8 will be the highest. For this particular OLED module, 1 is the best, because if you'll go for 2, then the text will go out of the screen. So 2 and 1 is having very huge difference in the size. I don't know why they kept it like that. May they should have kept a proper you know proper gradual growth in the text size, but I'm not sure why they did that. Let's move on. Next to that, set font. So we have different font families that we can add. As you can see here, we have already added a library for the font. So from fonts, we have added this free sans bold 9.7b font, and we are printing hello world. So basically print ln is used to print anything any text here. If we are having any any graphical functions like draw line or anything, then we can use that particular functions, or we can create such functions. Next to that, we are using again display function to display all this stuff. And once that is done, we give a delay. That's it, guys, for the code section. For white loop, we don't have anything. Now let's go back to the connection part and see how we connect it. So I'll display all the images on the screen so that you can understand how we are supposed to connect here. So it's pretty simple. For VCC and ground, we go with the 3.3 volts and ground pin. So LO is the 3.3 volts. So let's go with the 3.3 volts. So we are going to go here with the 3.3 volts. So LO will be 3.3 volts, and next will be the ground. So this is it. And next to that, we are having SDA and SCL pins. So those will be connected to D1 and D2. So SDA will be connected to D2 here. So SDA will be connected to D2 and SCL will be connected to D1. So let's connect it. So SDA is purple. I mean violet, sorry. So SDA will be connected to D2 and SCL will be connected to D1. So that's it, guys. The connection is done, and now we are good to go. We are going to burn the code and see if our project is running or not. So let's do it. Okay, guys. So now that we are done with the coding part as well as the hardware connection part, it's time to connect the NodeMCU to the laptop and then start with burning the code. Okay. So here, what you need to do is you connect the NodeMCU with the power cable, and then just connect that power cable to the laptop. And then in the IDE, what we need to do is go to the tools. Here in boards, we need to select ESP8266 and in that NodeMCU 1.0. So based on what board you are having, you can just select the board here, and then we need to go to the COM port and here select the COM port. So to check if what COM port you are having and you are not sure about it, you just go to my computers and then just check, right click on the manage, and in that manage devices, you can just check where the NodeMCU is connected on the laptop. So for which COM port, you can select it from here as well. So select, if you'll go here and select other board and port, you can just select here what options you need. So if you'll go here NodeMCU, you'll see that 1.0, 0.9 both are available, and here all the different COM ports that we are having already enabled or are connected. Now, first you need to compile. So if you can directly upload, it will compile and upload, but it's better always to first verify the code that we have written and then go with the uploading part, that is burning the code on the NodeMCU. Now, at the bottom, you can see that we are having all the updates of what is going on. So I think the verification is done and there is no error in the code. Next to that, we go and we can burn the code in the NodeMCU, upload the code. So here you can see first it will compile and then it will start uploading. So keep an eye on the display here. You can see that on the display we will get the screen once the code is fully uploaded. For the NodeMCU as well, you can see that it is getting all the data, that is all the code is being uploaded, and here you can see the progress as well. So here you can see we are getting a Adafruit logo and then the hello world program, hello world line. So if we'll go here in the code and if we'll change anything in this code, say for example, instead of hello world, if you'll put here, say for example, subs subscribe, subscribe, and then if I will upload the same code, then again we can see that the code will get compiled and it will get uploaded. So I'll just grab it here. and we can see that once the code is fully uploaded, we'll get here subscribe instead of hello world. So same code you can use, you can add multiple text after a certain amount of display. So you can see here that we are getting the subscribe subscribe string here. So you can add scrolling strings, you can set the cursor points to different location. You can also, there is one more thing that I have tried on this but I have not explained in this video because that is an whole lot another topic. That is how to create a small UI for this OLED screens. So that we are going to cover in future videos where I'll explain which tool we need to use to convert an image into bitmap and then into arrays, because here we need to provide those arrays of bits and then uh, show that bits here in this functions, and then the image or that particular UI will be displayed. So that's it guys for today's video. If you like this video, then make sure you hit like, subscribe my channel if you're new, and also add all the comments that you are having in your mind, queries, anything in the comment box. So a lot of people now they're asking, they are having queries but sometimes they don't ask in the comment box. So it's always good to have questions and I'll surely answer them. And also try it out yourself. If you want to buy all these things, then I'll just leave a link in the description. So make sure you buy it out and also let me know if you have made any other projects. Do check my Instagram page where I'll be usually putting up some reels and also in shorts in the YouTube channel, and follow them and try your own projects. So all the codes will be in the GitHub again, so check out the link for that as well. And that's it guys, keep innovating, take care, thank you.